Hi girls, so some people are asking questions about a particular question in the SciPAD where you've got centripetal acceleration, and it was one of the first questions which actually was quite tricky for you guys because it involves just, I guess, proving that when an object moves around a circle at a constant speed, it is still technically accelerating. So the first question in your SciPAD was just trying to get you to prove it using vector subtraction. Because as you know, acceleration is a change in velocity over the change in time. And we can assume that as we're going around a circle, if we have a point here and we move then to a point over here, that's going to take an element of time. So there is going to be a time difference from moving from this point to that point. But what we want to know then is, okay, well, what's this change in velocity? Because if we have any sort of change in velocity, then we would have acceleration. Remember that if you want to find the change in velocity, it's going to be your final velocity, take away your initial velocity. So what we've got here is two vectors, two arrows showing our velocity initially and at a final point. What we have to do is take these vectors together, manipulate them and find the difference. Okay, so what I've done is I've got post-it notes here. I've just kind of copied the vector, as you can see. So this is approximately the same kind of size and the same angle. So there's my final velocity. I need to take away my initial velocity. But when we use vectors and we combine them head to tail, and that is actually vector addition. So instead of adding vi this way, we want to subtract it. What we could do is consider adding vectors together in order to make them subtract each other. It's really strange, but we could add this vector with the reverse of the initial velocity. So here I've got the initial velocity. It's going this way. It's pointing down to my bottom left-hand corner of my screen. If I want the reverse of this, or the opposite of this, it would be going that way, wouldn't it? We would just reverse the direction. So what we can do is consider this now as the point, or the tail, and this is the head of our reverse vector. And we're going to add these together from head to tail. So I might just slip one under the other. Like this. And I can just redraw. That's where it comes out. So we're doing addition, but in a way that we're going to get the subtraction happening. So we've added these vectors vf plus negative vi together. We get a result, a resultant vector that goes approximately like this, from the start of all of this to the end of all of this. Okay, so a vector that about that angle, and that's about 8 centimeters long. So if you were to then take that information and kind of overlay it onto your circle, it's going to give you a vector that goes kind of like this in that direction. That is the change in velocity. You can see that it kind of happens in the midpoint of our initial and our final velocities, and it is always directed towards the center of the circle. The size of the arrow is just showing you the magnitude of that change. So we've gone from we've gone about a quarter of the way around the circle, so we're going to have quite a large change in velocity. So that kind of proves that we have acceleration, because remember, acceleration is a change in velocity. Velocity is not just how fast you're going, but the direction that is. So as soon as you keep going the same speed, but as soon as you change direction, you are changing your velocity. So feel free to pause there and leave it there. I am going to go through a couple more examples, just if you want to have another look. So here are another couple of examples that were from your SciPAD. So here's one circular path. We have an object starting here, moving around here. So it's actually going now almost halfway around the circle. Yeah. So that's quite a large change in velocity because it's quite a large change in direction. We're going from this way all the way around to this way. So we're going to expect a larger resultant vector, a larger arrow as a result of this. So again, here's my initial velocity, my final velocity. We want to add these together because we can't necessarily subtract arrows from each other. So in order to do that, we're going to go final velocity plus the negative of the initial velocity. So we're going to go from there to about there. You could draw this out. I'm just being lazy. Going at about that angle. Again, that's about that's our resultant vector. So that is it's about 8 centimeters again. I think this was a slightly different circle. Oh, the vectors are shorter actually. These were only 4 centimeters long. The previous page had 5 centimeter arrows. So if we consider that arrow there and we place it on top of our circle, right? If you imagine it's going there, it's giving us this kind of situation like that. Again, you usually find that if you overlay it onto a circle, it's coming from a point, I guess, in the middle of these two velocities, and then that arrow is going to head straight through to the center of the circle. Remember that the length of this arrow is the magnitude of that change of velocity. Here we've got actually quite a small change in velocity. We're going just from here, just a little bit around the circle, so we're only changing slightly. So these arrows are a little bit longer. These are 5 centimeter arrows. Here's our initial. Yeah, remember we want to reverse that, so we're going to have that as a negative velocity. And here's our final. So final, take away initial. Remember they have to be added head to tail. So here's your final, that's the tail to the head to tail, because remember we've reversed that, yeah? And then it's going down to there. So we've actually started about there, gone up with our final, added our reverse initial velocity, and so then our resultant is at an arrow a little bit like that. Looks like it's about 4 centimeters long. At that angle, it's going to be up here. Going from the center of our 2 points through towards the center of the circle. So I hope that explains a little bit about what was going on there in the SciPAD. Do not freak out if it's just too much of a deal. It's just another way of proving that when you're moving around in a circle, you are accelerating because and the acceleration is directed towards the center of the circle. Okay, so it's just a way to prove this. If you already are happy with that concept and you don't need to prove it, that's fine. But it's also another excuse to practice some vector subtraction, which is always a little bit tricky. So I hope that helped.